talk about this a little bit more, but just on this front sheet, just write that down. So in this problem, my probability of success is 0.02. Now, if you don't have success, you have failure or not success, right, depending on the terminology. So 1 minus p is the probability of failure. Which in this case, my 1 minus p is 0.8. So probability of success, they always use p for the variable for that. 1 minus p, and she does mention it here a little bit later. A lot of books for failure, instead of writing 1 minus p, they write q. So if you ever see a q, that's just the same as 1 minus p. And the last thing on this page I want to talk about is sample size. In this case, right, our sample size, which the variable for sample size is always what in statistics? So x is your random variable. Go way back. Little n, remember that? So lots of letters to learn, right? So n is my sample size. In this section, n is the number of trials. They use the word trials. But it's the same thing, and I should say sample size also. So make sure I have my pages in order. So on the next page, actually, she just talks about these things. Obviously, I don't have my notes memorized. So on the next page, it says, when you examine a coupon, that's your trial. So n is 10 in this problem. It's a number of trials. And again, when you have a coupon that gives you a free hamburger, that's a success. That's a good thing. And p equals 0.2. We talked about that one on the previous page. Now, remember in the last section we talked about x was our random variable. X is still our random variable, but what x equals in these problems is the number of successes. And that's actually on the bottom row. Right? So if you and 9 of your friends go somewhere, McDonald's, Chick-fil-A, wherever you go, and they have coupons, right? You want to figure out how many successes, how many you win a free hamburger. That's what the x variable is going to represent. Now there's 5 things that have to occur for an experiment or something like this to actually be called a binomial experiment or get a binomial distribution. There's 5 things that have to happen, and they're all listed on your next page. So I'm going to list them even if I don't need to. But one, you have to have a fixed number of trials. And what that means is when you start out, you have to know how many of these you're going to do. So on the example before, you had you and 9 of your friends, right? So the number of trials was 10. You can't have a binomial experiment where everybody in this class goes until somebody gets a winner, right? That's not a binomial experiment because the first person could get one or maybe the last person or nobody. So you have to have a fixed number of trials. So these are the keys to tell if something's a binomial. Second is you have 2 possible outcomes. And again, they call the outcome success or failure. That's the only two possibilities. If you don't like the word failure, you could say not a success. Because one thing to remember, especially I'm guessing a lot of you are going to the health science field, right? Because most people that take this class are health science or education. Is that true? So, to go into the health science field, let's say you're looking for a number of patients that have cancer. It's a nice sombering thought. So if you're looking for the number of patients with cancer, if you find a patient with cancer, mathematically that's a success. Obviously for your patients, that's not a success. But if you're looking for incidents, so take those terms with a grain of salt. So you only have two possible outcomes. Now the third one, very important, is the probability is the same on each trial. And we'll talk about that a little bit more in a minute. So going again back to our fast food restaurant, they produce a whole bunch of coupons, and if you go in and 20% of these are winners, right? Everybody has in theory, a 20% chance of winning. So the probability is the same. The next one is the trials are independent. And I would ask you what that means, but she put it in your notes. I won't ask what that means. Right? Just remember, independent means what happens in one trial doesn't affect the next one. So again, if you and 9 of your friends go and you walk in and you get a winner, your friend behind you could still get a winner. You do not affect his or her possibility of getting a winner. And last but not least, we talked about this before, X represents the number of successes. So these 5 things, keep in mind, because those are the 5 things that you have to look at to determine if an experiment is truly a binomial experiment. So if you look at the next page, actually she just restates all of the definitions we just talked about. The number of trials is N, that's your sample size. How many people are doing this, or how many times are you doing this? Probability of success is denoted P. Failure is 1 minus P. Right? Now she doesn't mention on here, but the probability of success and the probability of failure are mutually exclusive. Right? Remember that term from last chapter? You can't win and lose at the same time. If you get one coupon, it's either a winner or not. So these 2 things you might write down in your notes are mutually exclusive. You can't do both at the same time. And X still represents the number of successes, always. So that is the key out of this section so far. These 5 things and understanding your variables. So the next pages are some examples. So you're trying to find out if these are binomial experiments or not. So the first one is, there are 10 cards in a box. There's 5 red and there's 5 green cards in a box. 3 cards are drawn at random, and you replace the cards before you draw the next one. Let X be the number of red cards drawn. So that's my successes. And Again, we have 10 cards in the box. And the question is this a binomial experiment? So look down the list and see does it meet all the criteria. One, in this example, is there a fixed number of trials? How many cards are you drawing? 3. So the first one is 3 cards are drawn. So n equals 3. So that fits, because that's the number of trials. There's 2 possible outcomes. Is that true? Yeah, you have red or green. So that makes that one work. So far so good. 3. The probability is the same on each trial. Yes, it is.
Yes, because we're replacing the cards.
Because you're replacing the cards. Did she do something with you before on replacing cards? With or without replacement? So it is, because if you have 10 cards, what's the chance of drawing a green or a red, sorry, on the first draw? If I just draw 1 card out of here, how many cards are there? 10. How many are green or red rather? 5. So the chance of getting a red on the first draw is 5/10. What's the chance of getting a red on the second one? So it's the same, right? And the chance on the third is the same. So I'm meeting all these criteria so far. Number 4, the trials are independent. Yes, they're independent. And last but not least, it says X represents the number of successes. And yes, because they said so in our notes. It says X be the number of red cards drawn, because that's the number of successes, so number 5 is this. So this is a probability experiment. Because you meet all 5 criteria. Questions on that? All right, so I want you to take a second on the next page, if you would. Go through the exact same list. She gives you a little bit different problem. And see, I'll give you a hint, I'll see where it falls apart. It's gonna fall apart on us. Okay, so on the second example, do we still have a fixed number of trials?
Yes.
Which is 3. So n still 3, so we're good. Number 2, 2 possible outcomes.
Yes.
Yes. So that's 3. The probability is the same on each trial.
No.
No. Right? Without replacement, very important, because on the first draw, right, the chance of getting red, my probability, which is P stands for success, is 5 out of 10. Now the second draw, it's going to be different. We don't even know how different yet, right? Because on the second draw, if I drew a red one the first time, excuse me, what's the chance of getting a red one on the second one? 4 nines. Oh, chalk is not doing me good. Excuse me. Now, if I did not get a red, what would my probability again? 5 nines. If I keep going, the trials, are they independent? No. And I still beat the last one. So just know those 5 criteria, and make sure you can look through those and figure out if it's really a binomial experiment. So if you look at the next page, I'm going to give you a second to read that page. We've already kind of talked about this. I'm pretty sure you probably have before, but we'll talk about it. Okay. So like we just talked about, the problem on this last one we had, we didn't do replacement, so it's not independent. But something she might have mentioned before, but very important to know this page, if your sample size is less than 5% of your population size, we will consider this independent. Now, I don't know if she'll talk to you about this on your projects. I talked to my class. Are any of you picking your own data or using your own?
No.
I'm sorry?
She gave it to us.
She gave it to you, okay, darn. So I give my classes a choice, they get extra points if they pick their own data and go collect it. But one of the things is you have to have a population size large enough to make them independent, right? If you have a sample size of 30, you can't have a population of 50. It has to be a lot larger than that. So, they're independent if your sample size is less than 5%. Okay. So the last thing, next to the last thing out of this section, if you're gonna get to use it, is just like in the last section. Whenever you talk about distributions, binomial experiments, whatever it is, random variables, we like to find the mean and we like to find the standard deviation, always. So be sure you know how to find the mean and standard deviation of a binomial. So the mean in this case, which again is still u of x, is very easy to calculate. You calculate times n times p. What does n stand for again on these? Number of trials. Times, and what's the p stand for? Probability of success. So the mean is n times p. Standard deviation, remember, is sigma. So the standard deviation is the square root of n times p times 1 minus p. And again, sometimes you see it written like this, in PQ. So that is my standard deviation. So once you know what the number of trials that you're going to conduct, and you figure out what your probability of success is, your P, it's very easy to calculate your mean and standard deviation. So if you would, on the next page, read through that problem and determine what the mean and standard deviation of your x is in this case. So first thing, whenever you read a problem like this, try to figure out what each of the variables are represented by in the problem. So it says the probability that a new car of a certain model will require repairs during the warranty period is 0.15. The dealership sells 25 such cars. So what is 0.15 in this problem? What variable is it represented by? P. And once again, the term success, you gotta take with a little grain of salt, right, in math or statistics. Because the probability that you have a problem with your car is 0.15. Most people don't call that a success, right? But for this problem, that's what it is. Then it says the dealership sells 25 such cars. So what variable goes with 25? M. And binomial are very easy to calculate the mean standard deviation because you only need two things, n and p. So the mean will be 0.15. I guess to be consistent, I should put it in the right order. So 25 times 0.15. Yeah, let's see. She got 3.75. And then my standard deviation is the square root of n times p times 1 minus p with that. Everybody match those numbers? So again, remember your mean, all through statistics, does not have to be part of your data set. You can't have 0.75 cars with a problem, right? Just like the average family has 2.4 kids. So, same idea, but what this means is on average, if this dealer sells 25 cars, whatever this model is, sells another 25, and they keep doing that, or different dealers, they can expect on average, almost 4 of those cars will come back under the warranty period. And we'll talk more about standard deviation actually in the next section. The standard deviation says how wide that dispersed, what percentage is within that. Questions there? All right. Now, one thing she does not go over in here, and this is the part that you don't have to cover when you go read your book, is how to calculate the binomial value. Like the leading problem, remember, said you and 9 of your friends go get coupons. What's the probability that 3 of you actually win? Right? So you're not going to go over those calculations in this section. So understand the 5 criteria and understand how to calculate the mean and standard deviation. And she'll fill in the rest. Next slide. Questions to that point? All right. So in that case, we'll give you another little break.